Addition of whole numbers, the set model. The set model is pretty close to the concrete model, which is when you have things in your hand and you actually move them around. That would be the concrete model. The set model, we have pictures. And notice we have two sets, set A and set B. The number of members in set A are 4. The number of members in set B are 3. And if you form the union, that means you put them all together, you add the two sets and form one bigger one, where all the members of set A and set B will be. They will be in the union, and all together, these 4 plus these 3 will give us a group of 7. Another way of modeling addition of whole numbers is with the number line. The number line sometimes is called the measurement model also, number line model or measurement model. So we're going to illustrate how we could use the number line to show that 4 plus 3 is 7. So one thing, make sure that the arrows that you're going to draw are not on the line, they're on top of the line. So we're going from 0, you always start from 0, move up 4, and then move up 3. So we've moved a total of 7 spaces. So 4 plus 3 is 7. Closure idea is the following. You start with a type of number and end up with the same type of number. You say, what do you mean by type? Well, we have whole numbers, natural numbers, rational numbers, integers. So if you start out with a whole number and add another whole number and your result is another whole number, then we say that set of numbers, in this case whole numbers, have closure. Example, which of the following sets is closed under addition? So this set they give us to us in a complicated way. We have to see what description it has and then produce the members. So they're telling us how to produce the members. They're saying the members from here are 3n such that the n is a member of the whole number. So what they're saying in a more simple way is go to the whole numbers, which are 0, 1, 2, 3, 4, and so forth, and start replacing that n. So 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And you go on and you go on. We put these little dots, ellipses, to say continue the pattern. So here's our set. Now, how do we know this set is closed under addition? Well, I should be able to take any two numbers, add them, and the result should still be in the set. And actually, I could even take the same number. I could say 0 plus 0, that gives me 0. Is 0 in the set? Yes. 3 plus 9, 6 plus 12, 9 plus 12. And when you add those numbers, if your result, if the sum is still in this group, then it's closed. We're going to see that doesn't happen all the time. So right here, I'm giving you in writing what I said in words. Here's our set that we were talking about. And we're going to take 0 plus 0, and I get a 0. The 0 is in the set. 3 and 9, they're in the set. And I'm going to add them. I get a 12. Is the 12 still in the set? Yes. I'm going to take the 6 and the 0. I get a 6. Is the result still in this group? So since no matter which two numbers you get and add them, and the result is still in the group, we say that T is closed under addition of whole numbers. Here's another example, same question. Is set C closed under addition of whole numbers? So I should be able to add these numbers and end up with a number that's in that group. And you could pick the same number. So 0 plus 0 is 0. I'm still in this group. 0 plus 1 is 1. I'm still in this group. How about 1 plus 1? 1 plus 1 is 2, but 2 is not in the group. This guy left the group, not in the set. So C is not closed under addition of whole numbers. Set C. Then we have some properties, addition property. When you're adding numbers, the order doesn't affect the result. If that's the case, notice A plus B gives me the same result as B plus A. That means that operation, addition, has the commutative property. Notice it's not commutative, it's commutative property. The associative property says that if you were to group in one way or group them another way, if that property is present, I should get the same result. I could group it this way, or I could group it this way, and I get the same result. Then we say we have the associative property. Subtraction of whole numbers. These are models. So the takeaway model, here's the set, and I'm going to illustrate 8 minus 3. So the total here is 8, and I'm going to demonstrate what it means to subtract 3. To subtract 3 means I remove 3 from the set, which will leave 5, which is this 5 that you see. We also could illustrate by using the missing addend model. Say, what in the world is that? Well, remember, an addend are the numbers you're adding. So the 3 is an addend. What goes here is an addend. This was called the sum. So the addends, the things you're adding, the numbers you're adding, and the result is a sum. Okay, so the missing addend, notice something's missing here. So we're asking 3 plus what equals 8. Notice this is a very good model to start the students thinking algebraically, because instead of writing an empty box or a blank, we're going to use an X. The X is the one we're trying to figure out. But we don't say that at this point. You stick to the box. So 3 plus what gives you 8? Well, 3 plus 5 gives you 8, because 8 minus 3 equals 5. And then right here, we're saying the same thing 2 different ways, one's with addition and one's with subtraction. So right here, we become aware that addition and subtraction are related. They work together. We also have the comparison model. So we're going to illustrate 8 minus 5 equals 3 using the comparison model. The comparison model, you could ask yourself the question, 8 minus 5 equals 3. How different are they? You say, who? 8 and 5, how different are they? That's one way of saying it, or how far apart are they? So here's the 8, here's the 5. So you cross out what they have in common, and how different are they? They're different by 3. So 8 minus 5 is 3. Notice this is getting us ready to say the difference. And when we say the difference, they are different by 3. The difference is getting us into the idea of subtraction. The difference, subtraction, we're talking about the same thing.